Well, thank you all for joining us today. I know I see some people in the back there. Maybe they'll join us as well. Definitely super excited for this session. I know we were chatting backstage as well, but maybe a quick introduction. My name is Kishore. I'm with Plug and Play Ventures. We invest in mainly the early stage side of things, pre-seed, seed, Series A. Some of the portfolio you might have heard of. Einride is one of our portfolio companies as well, also in the autonomous trucking space and electric trucking space. We also invest in robotics and physical AI. You might have heard of a company called Maven Robotics, or even Dyna. These are all portfolio companies of ours. So yeah, we focus quite a bit in this space. But maybe enough from me. Quick round of introductions from you guys. Who are you with? What do you guys do? And maybe one stat or like a metric that is best describing of the company you're building right now would be great. Yeah.
Can everyone hear me? Awesome. Great to meet you all. Last session of the day. So I'm Christian Stano. I'm the field CTO at Anyscale. We're the company behind the open source framework Ray that powers a lot of the data, training, and inference pipelines for most of the physical AI companies in this room. Torque is one of our awesome customers. And so what we really do is we help customers and companies build physical AI better, faster, cheaper. And my role at Anyscale is to help engineering leaders like those on the stage here to understand how autonomy economics actually work. GPUs, CPUs, and how do you actually build the team around that? And then the data point for our company, so Ray in 2027 will power about $50 billion worth of compute and around 2 million clusters per week, just to give you a sense of the scale that we're at.
Awesome. Hey everybody, my name is Shubham, head of AI at Kodiak. At Kodiak, we are building AI driver for autonomous vehicles. And this is the AI driver that generalizes really well across multiple environments and multiple platforms. We have deployed our technology on Class 8 semi-trucks, F-150, tracked vehicles, multiple platforms across highways, off-road, industrial. These are all just single AI driver that drives all of these vehicles across different platforms. Maybe one, since you talked about metrics, we are already deployed driverless across Permian Basin. We have 28 driverless trucks as of March of this year. We've done over 23,500 hours of driverless paid operations. So we are just operating commercially 24/7, day in, day out.
Excellent. Andrew Culhane, Chief Commercial Officer at Torque. Torque, very similar in certain ways to the folks to my left and right, really building that software stack that powers self-driving trucks. Where we differ is we have very close OEM partnerships, and as this kind of part of the session is all about what it takes to launch and scale these, kind of an interesting stat, Torque has been around for 20 years. So I've been with the company since we were 5 people, a lot of startups here, grad students sitting in a corner trying to figure out how to make a real business of self-driving. And over the years we did that in areas like off-road, mining, military, a lot of the things that are becoming exciting again. And really what that kind of informs is what it takes to go beyond cool tech to actually commercializing and getting this type of technology out into the wild. What partnerships, what ecosystem, what economics lead you to that success? So super excited for the panel.
Hello everyone. Again, thanks for staying here. I know this is the last session, but going to be an exciting one. My name is Xiaodi. I'm the CEO of Bot Auto. What we do is level 4 autonomous driving. I know that we got a lot of colleagues in doing this. One of the things that differentiate us is that we are a trucking company. So we operate on our own. And well, in my opinion, this is the way that we can go to commercial in a shortest path. A number that Kishore has asked. Today, average truck driver driving the truck with a cost around $3 per mile. And with our autonomous driving technology, we operate it by ourselves. So if you're using an all-inclusive way of calculating all of the costs, we are below $2, meaning that we are making money in every mile rather than losing money in every mile. And I think that we are very proud of that.
Lovely. Thank you, gentlemen here. Maybe before we get into deeper questions, in one sentence, when can you go fully driverless? I believe Kodiak already may have done that on the interstate, I believe, if I'm not wrong, but maybe from the rest of you guys too. When can you go fully commercial? And maybe what's one obstacle that maybe you see as like one of the reasons why it could not happen? Maybe for Christian here, I know you're more on the software side of things. What do you think could be a software constraint? Maybe we'll kick it off with you.
Sure. So I work with a lot of customers in autonomous trucking, autonomous vehicles, ag tech. So a couple of our other customers are like Bonsai Robotics, Bedrock Robotics. So I see a lot of different patterns here. The two biggest bottlenecks from the software side that I see, one is the data pipeline side. It is so expensive to aggregate terabytes of data per truck every single day, and I think, Xiaodi, you talked about you want to make money and like the economics work. On the data side, you have to have a way to activate that data, and so I see a lot of customers who struggle with that, both from how do you write these pipelines, and then how do you actually secure the compute, the CPUs, the GPUs, to then process that data, auto-label videos, and activate that for your training loops. The second piece is sim eval. You have to make sure that it's safe. And that's a very computationally intensive and challenging problem to solve. So those are kind of the two blockers that I typically see for customers to be successful here. I think a lot of the folks on the stage have either already solved it or are in the process of solving it in really awesome ways. But a lot of the customers I work with that I see success with really invest in those two. Quick plug for Anyscale, we help with that. But that's where I see a lot of the challenges.
I totally agree with the data part as well. By the way, on driverless, yeah, we did go driverless around December of 2024, and since then we've gone from 2 driverless trucks to now 28. We have 100 committed truck orders already. We are trying to bring that on highway by the end of this year. But data mining, like you said, I think that's one of the biggest challenges. So we operate over 1 million miles every single year. And that means there is a lot more data that you can process. So you have to build your system in a way that you understand what is out of distribution. You sort of build your system around capturing that kind of data and how do you auto-label them. Like you have to have this AI flywheel that is continuously improving and only focusing on the problems that truly matters. And like if you haven't solved that problem, there's no way you can scale. So I think for anybody who is already sort of in production, I think this is one of the things that they must have already solved as well.
Yeah, I can touch on the data side in a slightly different way, and that's that fundamentally our obligation in this industry is to make the roadways safer, right? Yep. And we have to do that with data, not speculation. What are the SPIs? What are the KPIs? What are the metrics that we can prove to ourselves, to the general public, to other road users that we are making that roadway safer, right? That is hurdle number one, and I think that is an obligation all in this industry have to internalize and have to share. We talk about what gets you to scale, it is actually what Xiaodi hit on, which is what unlocks total cost of ownership for those trucking companies, right? The first truck, the 10 trucks, even the 100 trucks, you can get away with being a bit of a novelty, right? It's interesting, it's exciting, they'll do pilots, they'll try a few things here and there. Trucking is a beautiful industry because it is a non-emotional industry, right? Everything comes down to economics. And so when you have those metrics for economics in place, then you have that ability to scale. But it starts with that first thing of being safe, being trusted by your partners. And there's a whole liability discussion we could have one day up here. But at the end of the day, once you meet that first hurdle, the next hurdle really gets down to the economics.
All right, great answer, Andrew. I think the advantage of being the last one answering this question so that I can basically connecting back to each one of you. Let me try that. So Andrew says a lot of safety. I think it's very important to commercialize autonomous driving. Keeping that in mind, there are always going to be crazy drivers on the road. And it's not a truck's responsibility to dodge the bullets. So when we talk about safety, we talk about liability. And it is, I think, this very big distinction where I was even a misconception that a lot of people say, oh, how can you do this? How can you do that? Come on, man, we don't need to do this and that. The truck drive all the way following the laws of physics. And by doing that, we need a lot of simulation in order to guarantee that in whatever situation, the truck is not going to infringe the right of the way. And that liability determination is actually more important than just surviving the truck in every crazy scenario. So that's why, connecting back to Christian. connecting to Shabam is, I think driverless, as Kishore has said, is actually coming. We are operating, we opened up the human-less operating commercial lane between Houston and Dallas. And I think it's important to determine to define what is driverless. Driverless should not be that you have someone in the right seat, or you redefine some human being as an observer instead of a truck driver, or instead of a truck driver in the driver's seat, nor someone in the back seat. You have to have no human in the cabin. That's very important. And also, you have to make sure you have a limited amount of human attendance in your remote or whatever center, like operating remotely. So only with that, you can scale the vehicle. And for us, I think it's important that we finish all of these things, which we are already doing that. Driverless, already box checked. Commercial, already box checked. We're hauling commercial freight every day, like now. And the last thing is scale the commercial. And that thing comes back to my original point. You got to make money in every mile. Otherwise, how can you scale? It's going to be a scary financial result if you scale, if you are not ready.
Thank you, guys. I hear a lot of data, and I hear a lot of economics to work, which I know you guys know as well. I have a couple of questions on that. But maybe before that, Xiaodi, please hold on to the microphone. We'll start with you. So you mentioned, you're owning the trucks, you're hauling the freight, you're running fully driverless, especially from Houston to Dallas, as you mentioned as well. Why is owning the freight the right bet, and what does it teach you that maybe a licensing model doesn't structurally do?
Okay, thinking about this, you have a good model, you license it. Maybe you have a easier to digest model. Thinking about a coffee machine. I wanted to buy an espresso machine at home, but my dad always criticizing me, saying like, if you're buying this, you're only using it 5 minutes every day. It's a terrible asset, right? And I think the only way to make sure that this great piece of technological crystallization is being used 24 hours a day is that we operate it so that we can make sure that it's used 24 hours a day. I think also I respect Kodiak's model. If you have your customer using it 24 hours a day, that's also good. But if you're only selling the service, say, okay, I sell it to UPS, and UPS can use whenever they need to use it. Guess what? They're only going to use it as a backup plan rather than a main plan. Because you're also going to charge them the same amount as you charge for human drivers. So I think making sure that we do the engineering in the right way so that we can maximizing the utilization of the truck is the key. Removing the driver, on the other hand, is not the final promise, not the delivery for autonomous driving. That's kind of a byproduct that we have to do, but that's not the answer. That's not the ultimate answer. The answer, you have to max out the utilization. Otherwise, autonomous driving company is definitely going to lose money and getting out of the business.
Actually, that's great. And I know you have something to add to that, Andrew, but maybe I'll put my question up, and please feel free to add to that as well. So you guys did kind of an opposite bet in a way, like Daimler's manufacturing, Freightliner, customer base. On the commercial side, what kind of integration and partnership does this bring, like that a startup carrier typically does not? And does it slow you down at all?
Yeah, so very different end of the spectrum. And maybe I'll kind of highlight that if you know the freight market, there's a lot of ways into this market, right? And I think that's one of the important things to kind of highlight is there are carriers of all different sizes. Aside from seeing a truck going down the road, they may look wildly different under the hood. And that's sort of where our approach differs a bit. I think early on, and you heard Peter, if you were here this morning, we will do the same thing in terms of a captive fleet, but not with the intent of staying a carrier. And I'll quote my previous boss, right? Very rarely are you the best in the world at more than one thing. And so Torque's long-term model leverages us, on the software on the AI side. We have Freightliner and Daimler Truck North America, who is proven as the best in the world OEM by both market share and any other metric you want to grab. And at the end of the day, because of that relationship, we also have relationships with all of the major fleets. And those folks specialize in running things at high velocity, high asset utilization. That is their business. But we have to build it up and prove it with them along the way. And so I think there's that huge advantage of being able to build vehicles at scale, software at scale, and operate at scale. And those are three uniquely different challenges that we get to leverage, I say, the best in the industry at all three. So I think that's kind of the first piece of it. You ask about the speed question. it all depends on what race you're running, right? This session is the race to driverless, right? And that race to extremely high scale and extremely high impact does need a different level of rigor to build both software and vehicles at that scale. And so does sometimes that add some friction to the design process? Absolutely, right? It's easier to own it all and run really fast. But if you want to get to the scale, our belief, right, and again, there can be many on stage, is that you need that. And then the real magic happens when you figure out how to blend rapid software iteration cycles with your traditional OEM cycles that get you that reliable hardware, that maintenance, all those things, all the ilities that go with it, right? And so are there challenges with that approach? There's challenges with any approach. That's the one that we've really leaned into because we have that longer term view for that scalability and profitability.
That's awesome. I think kind of not an opposite bet in that sense, but it's all going towards the same approach of things, which is great, I think. Shubham, you actually pulled the driver out, like 23,000 plus driver's hours is what I've heard. What was genuinely the hard part of getting there? And since you're on the AI side, how much of this is actually end-to-end learned systems versus just like code that you can kind of inspect?
Yeah, maybe one thing I would say quickly, maybe in response to Xiaodi, in industrial space, usually the way people get paid is on an yearly basis. That's how drivers do get paid there. Specifically in Permian Basin, nobody wants to go there and work, right? So it gets correct, exactly. So our customers actually need these trucks, and they need these trucks to be driverless. We also get paid on an yearly basis on the service. So if they don't want to use it, it's fine. We get paid regardless. But one major distinction here is our customers actually own and operate the truck, which is sort of the business model that we have taken. And there are challenges with that. If one truck goes down, we can't just replace it with another truck because it's not us operating those trucks. So therefore, it must be up most of the time. And that's where the robustness really comes from. We have to make sure that our technology is robust. It can work 24/7 in whatever situation arises, whether that is, I don't know, heavy rain and whatnot. We need to be able to deal with it. There's nobody inside the truck or watching it remotely, so the technology has to be there. Maybe talking about the question that you asked, I think one of the major challenges in being able to do this is like how do you handle some of those tail cases? Like how do you handle roads getting washed, or some of the things that we have seen is cowboy riding a horse, or like different kinds of animals, snakes. And as you scale, these kind of out-of-distribution scenarios become more and more nominal. And being able to put together a safety case that you can convince yourself that it is safe to go out there and drive all the time, and you're like specifically out there where we are actually towing 300,000 pounds, you need to be able to prove that you're going to be safe. Like end-to-end versus modular doesn't really work. It doesn't really matter. Like both has its own place. We specifically take a hybrid approach where we do have our modular stack that is currently driverless approved. That's what's running. In parallel, we also have end-to-end VLAs. There are different kind of scenarios that they can handle better. The end-to-end sort of kind of learns from human behavior, right? So how do you react to those washed out roads or like puddles in a human-like way? But at the same time, when you have this modular kind of an approach, you can really probe all the corner cases and prove that you're going to be safe regardless of what happens out there. So yeah, there are lots of challenges to going driverless. You have to sort of think about the technology, the safety case, and the product usability. And those are the three major pillars that we sort of try and push on.
No, yeah, I agree. I think there's a lot of challenges specifically with some of the edge cases you mentioned as well, right? Tackling that needs, like you said, maybe the hybrid approach of things. Maybe Christian, since you sit on more on the software stack side of things, right, with multimodal data pipelines, inference costs, so on and so forth, what is like the real bottleneck to scaling autonomy? And is it like more on the training, inference, data processing, or is there something else to it? Yeah.
So I think everyone, when they start thinking about these pipelines, they budget for training. It's the sexy part, it's the fun part, it's what you pay researchers a lot of money to do. But that's usually not the bottleneck, GPU supply chain aside. Usually the bottleneck is kind of what we all mentioned before, which is the data. What a lot of people don't recognize is that, let's say you go out and you buy 500 of the most expensive GPUs. You're essentially going to buy those, and it's like buying a Ferrari and parking it in the garage while you take the Honda Civic to the store, waiting for things like file I/O, waiting for things like image filters. And so that's what I actually see as the bigger bottleneck is data is essentially just a line item on a spreadsheet until you really activate it and you have a way to feed that into your training loops. This is one of the things that we really focus on at AnyScale. So like Torque is one of our customers, for example. We help them go from 30% to 90% GPU utilization because of the way that Ray and AnyScale handles that data streaming pipeline and gives you the ability to offload some of the less intensive, less complex components of it to CPUs and cheaper GPUs. So I work with Neil, who's on Andrew's team, and they're doing phenomenal work to both increase their GPU utilization, decrease their cost, but also at the same time quadruple their data that they're feeding into these models. And that's a really, really hard problem to solve. And so the bottleneck there is, do you have the right systems, the right infrastructure, the right pipelines, and the right people to then go and solve that problem yourself? This is exactly what we solve at AnyScale. We also see a lot of people in the industry, once they solve this, then you can kind of move on to like the harder, sexier problems of building end-to-end VLAs, getting into advanced techniques with sim evals. But like I said, the data is just a line item on a cost spreadsheet until you can really activate it, use it, and then feed it efficiently into your training algorithms.
I actually have something to add in there. I think I would say also to the audience, data is the past, compute is the future. Yeah.
Interesting, because I think I know I'm excited about the data question that I have itself, about the moat itself. Maybe I'll jump into that, and we'll start with you, Christian. Everyone does claim data is like a part of what their moat is. Between the four of you, of course, all of you have like different data positions in that sense. So when and how can data become a moat, and when can it compound into an advantage, essentially?
I love that you said compute is the future, because I think that is how you turn data into a moat. Otherwise, you're just paying a really, really expensive S3 bill. And so that, like, at least from what I'm seeing with like folks like Torque, other people that we're working with, not even just within robotics itself, in other industries, you really have to activate that data. And one of the things and patterns that we're seeing is these GPU in the loop patterns within data pipelines. So traditionally, you have tools like Spark that you'd run through like a massive ETL pipeline. That doesn't work anymore. When you get into multimodal data, videos, images, text, you really have to use GPUs as part of those data processing pipelines in order to activate that data, and that GPU is the compute layer. So then the question shifts from how much data do I have, which is what a lot of people think about from the moat, to how much can I actually activate that data, and then what do I need to then do that? And a lot of that's compute. And the next question that follows on is, how do I handle the economics of that? Because GPUs are expensive, they're constrained, there's a supply chain crisis around it. So I'm glad you mentioned compute, I love that. That's exactly what I'm seeing as well as people try to create a data moat.
Because I think that maybe add up something here, because a lot of people are thinking about data as 5 years ago or 10 years ago, that's probably data is the moat. But I'm really so sick of this data is the moat narrative, because hey, we're living in 2026. Just go back, check your calendar. ChatGPT has introduced like 3 years ago. So the landscape is that previously annotating the data and keeping it in your own repository gives you so much unfair advantage in training your deep learning, but now deep learning is trained by having unannotated, unstructured data. And for truck driving, it drives like 20 hours a day, every day, and what does that make to us? Basically infinite amount of data. And what we need to leverage is using compute to extract the most valuable things of it, and importantly, without involvement of human, or minimal involvement with human. And that's the only way you can basically turn a workshop into a next generation factory.
Yeah, I'd even add on to put that in better perspective. We just released a whole data set publicly because that's not the moat, right? Around long-range driving or high-speed driving. So to put that in very tangible perspective, you can make it public and it's still not going to differentiate somebody.
So again, going back to the compute part, basically, right? Anything to add?
I have a little bit of a conflicting view on this. It's not that data is not a moat anymore from my point of view, or like data is not important. It's finding the right kind of data, utilizing the compute. So just automating that part end to end so that if you see a helicopter landing in front of the truck road, like you want that data to feed into the model. And everything else may be just boring, like 99.9% of the driving of over 1 million miles. I don't think we need all of that. We just need the part where we know, hey, our model probably has never seen something like this. So being able to recognize that, sourcing that data, and putting that into your training set. But yeah, it can only be enabled using compute.
Unstructured data is actually just a natural consequence of your day-to-day operation.
That's true. I think these kind of one-off scenarios, like you mentioned, right? It's a continuous process. You're going to have to need those things, like basically almost every single day as you keep seeing these new scenarios come up. We talked about economics, and maybe I think I have time for this question. So a lot of driverless miles right now are being watched by remote, like teams, safety teams. Let me jump in. Maybe Xiaodi, you have thoughts on this. I know this could be an obstacle when you are scaling. So maybe what's the one thing that you see as an obstacle, something that you're doing more manually or more expensively that should go away before economics can actually work?
Oh gosh, thank you, Kishore. I really like that question, and I think the whole industry needs a standard. You don't need to get a very complex standard. Just one standard is how many seconds can a vehicle keep things unattended without a human assistance. So starting the moment where the vehicle, of course, all by itself, finding something that requires human attention to the point where the human attention is guaranteed to be provided to the vehicle. I call that like basically safe response window. Easy to understand, safe response window. If you have a safe response window for 5 seconds, you will never scale your business. But the reason why I'm so frustrated because there are so many companies assuming some human in the backseat or in some remote operating center doing that job, and they can still claim themselves driverless. I think this is so frustrating. You gotta do that. The machine has to handle everything. Like for example, in our company, we do it for 1 minute. You don't need to need any human in 1 minute of time for a safe response window. You gotta have a long enough window for that. That's the number 1 metric everyone should be focusing on to basically making sure that our industry is safe enough.
Yeah, I think I would even echo that, in a slightly different way, which is really think about what is that ratio, right? Because at the end of the day, if our value prop is no driver in the seat, if all we did is put them in a different chair, what did we really do, right? Different chair in the cab, different chair remote. So what is that ratio? And then, candidly, it comes down to how good and generalizable is your autonomy, because then your remote assistant is really exception handling, and the better you process that new data, the better you grab those scenes, the fewer exceptions you will have, right? And so I think that has to constantly be the mindset, and this is where is it data or is it how you process that data, how you can translate it, how you can retrain models quickly to handle those exceptions. That's the actual value prop of that remote assistant, is really reducing it down to rare, unique exceptions. But once it's happened once, it's no longer an exception, right? It's back into the pipeline and should make the models better each time. So would be our take from the economics there.
I agree 100%. There is no way you can scale commercially if you have like one-to-one monitoring, or if you have a person sitting in the observer seat. There's just no way. We have what we call as the call for help system, where the truck itself recognizes, hey, there's something complex, let me send a call for help, and seek help that way. And we want that ratio to be minimal as possible. But most of the situations, vehicles should be able to handle by itself 100% of the time.
The one thing I'll add on top of that, I don't operate a trucking company, so my perspective is a little bit differently. But I think, Andrew, similar to what you said, One of the things that I see a lot is when you're building these really complex models, you have these really expensive human engineers that are just banging their heads against data. And so as we're all essentially AI companies at the end of the day, it's really, from my perspective, about how do you automate that flywheel from data to training to inference to fleet collection and then back. And then how many like human loops and how much does that cost to actually automate that? So like at least from my perspective in the software layer, that's where I see a lot of the remote operations side kind of moving away.
Lovely. I think we're actually up on time here, but thank you, Christian, Shubham, Andrew, and Xiaodi for jumping on the stage for us here today and sharing your thoughts on it. And thank you for the organizers for running such a smooth event. But yeah, thank you all. I hope you guys found this insightful, and hope you enjoy the rest of the event as well.